In the last video, we looked at congruent polygons, and we saw that we had to have all angles of one polygon congruent to all angles of another polygon, and all sides of one polygon congruent to all the sides of another polygon. In the following two videos, we're going to look at special cases for triangles where you actually don't need to have all 6 parts congruent to prove congruence. And in this one specifically, we're going to look at SSS, which means side, 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 and SAS, which means side angle, side congruence. So first off, we know that in side, 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 the side, side, side postulate, I can say if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. So in triangle BAC and YXZ, if I have 3 corresponding sides that are congruent, then I can say that triangle BAC is congruent to triangle YXZ. That's because I have this side congruent to this side with the 2 tick marks congruent to this side with 2 tick marks, and this side with 3 tick marks is congruent to this side with 3. And so I have 3 sides that are congruent, and therefore I can prove they're congruent by using side, side, side postulates. So, a lot of this unit we're going to be using proofs. So let's go ahead and start a proof. Of course, the first thing to do on any proof is to take the givens and mark up the picture. So AB is congruent to CB, AD is congruent to CD, and finally, you know that this middle segment is in both triangles, so it's congruent to itself. So I have 3 sides of 2 different triangles that are congruent to each other. So now when you go to write the proof, you start with writing your given. So AB is congruent to CB, and that's a given. AD is congruent to CD, that's our other given. And finally, what you write on the top, if you have the following, you write these on the top: reflexive, linear pair, vertical angles, anything like that, you're going to write on the top line. So BD is congruent to BD, and that's because it is reflexive. It reflects on itself because it's the same thing. And now just from this proof, you already have 3 different sides that are congruent. So all you have to do is finish off the proof and say triangle ABD is congruent to triangle CBD, and that's by the SSS congruence postulate. So it's a pretty basic and straightforward proof. I want you to pause the video and try this one out. This one has an extra step in it. All right, let's mark up the picture. HF is congruent to HJ. FG is congruent to JK. And H is the midpoint of GK. So if H is the midpoint, that makes this segment congruent to this segment here. So let's go ahead and write our givens out now. HF is congruent to HJ. That's a given. We also know that FG is congruent to JK. Not meaning just kidding, but the segment JK. And then H is the midpoint. I'm just copying the given of GK, and that's our given. Well, from what I have up top, I have 2 segments that are congruent, but this doesn't actually say a segment's congruent. So I need to come down below and say segment GH is congruent to segment KH. And that's because that's the definition of midpoint where I get 2 congruent sides. Now I have 3 congruent segments, so I join them together and I say triangle FGH is congruent to triangle JKH. Remember, you want to always end with what it says to prove, and that's by SSS congruence. All right, our second postulate in this video is side angle side. This says if 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. In other words, if I have 2 triangles and I can match up a side, another side, and the angle in between them, then they're congruent. That included angle part is the part that's going to confuse you the most. Make sure you realize that that angle is between the 2 sides. So an example where that would not be between would be here. If I did this, and I put the angle right here, that angle is not included. It's not between the two sides, so you cannot use SAS on something like that. All right, you hopefully have proofs right down now, so pause the video and try this one out. All right, let's mark the picture. AB is congruent to AD. AC bisects angle BAD. So it's telling you it's bisecting an angle. So it's an angle bisector. So right there. And you also know that AC is congruent to itself. So already it looks like you have side, angle, side, side, angle, side. So let's go ahead and write the proof out. AB is congruent to AD, given. AC bisects angle BAD, and that's a given. And finally, whenever you have a reflexive or a vertical angle, you write it up top. AC is congruent to AC, and that's reflexive. So from the bisector, you know that angle BAC is congruent to angle DAC. And that's the definition of bisector. So now you have a side, an angle, and a side, so you just join them together. And you say triangle ABC is congruent to triangle ADC by side, angle, side congruence. Now remember to do the homework and to keep practicing the proofs, because the way you get good at these is by practicing and practicing and practicing some more.